Hello folks, we come to the part 3 video of this miscellaneous exercise, and let's see what we are supposed to do. Question number 5 shows that there is f of x equal to x cube. You have to show that it is injective. Injectivity is like normal, how we go about the thing. So let's consider f of x1 equal to f of x2. So we'll have x1 cube equal to x2 cube. We'll take the cube roots on both sides. So that way x1 will become equal to x2. So therefore f is injective. That's about it, and that's how we show that f is injective. Now next question says that you have to give an example of a function from natural numbers to integers and a function from integers to integers such that g of f is injective. Okay, but g is not injective. So in the textbook itself they have given a hint, so we can take that example and we can see how this is happening. Okay, so let f from n to z be defined as f of x be f of x is x, and g from z to z be g of x as modulus of x. Let this be the definition. And let's see now how we can show that g of f is injective. So consider g of f at x1 equal to g of f at x2, right? So by definition it is g of f of x1 is equal to g of f of x2. Now if we know the function is identity, so x1 g is x2. Now g of x1 g of x2 by definition is modulus of x1 equal to modulus of x2. We have to see what is this x1 and x2. Since we had started from f, this x1 and x2, they are belonging to natural numbers. So they start from 1, 2 and so on onwards. So modulus of x1 and x2, they are all natural numbers. So obviously they are going to be positive, right? So modulus of x1 is going to be x1, modulus of x2 is going to be x2. Why? Because we had started from natural numbers. So what has happened? Starting with GOF of x1, thus starting with GOF of x1 equal to GOF of x2, we have reached x1 equal to x2. So GOF is 1 to 1. What is injective? But they say it is G is not injective. Yeah, true. But you take you take G of 2. It is modulus of 2, 2, and you take g of minus 2, that is modulus of minus 2, that is 2. They both are going to some, that's not 1 to 1. Therefore, g is not 1 to 1. Right. We have learned now from two places, if it goes to one place, then it cannot be injective. It should go to single places, right? So that is how it is not 1 to 1. There was not much effort because the example was given in the textbook itself. We are just justifying how this is coming correct, right? So for us, what came out to be successful is because of this natural number. That's how we could get it. Okay, next question is also same way, where they give us an example, and again the hint is given in the textbook. We only have to justify it. They tell that there is a function from natural to natural, g from natural to natural, g of f is onto, you have to show, but f is not onto, somewhat like this way, right? So they have given us the definition. Let f from naturals to naturals be defined as b f of x equal to x plus 1, and g from naturals to natural be g of x is 1 when x is 1 and is x minus 1 whenever x is greater than 1. Okay, so that is a g definition. We have to show that g of f is onto, right? Just let's understand this function, then it will be more easier. So g of f, so let's get the f function. F function is starting from natural, so 1, 2, 3, 4, 5, so on. So f, right? How is f defined? X plus 1. So 1 will go to 2, 2 will go to 3, 3 will go to 4, 4 will go to 5, 5 will go to 6, and so on, right? And then we have this g. How is this g defined? Of course, x is going to x plus 1, they have defined. Okay. 1 is not coming from anything. Okay, 1 will go to 1 by this definition. 2 will go to 2 minus 1, 1 again. 3 will go to 2 minus 3 minus 1, 2. This will go to 3, this will go to 4, and so on. This is how the function is defined. Now what they say is you have to show that GOF is onto. That means you take anything, you will have a preimage, right? So here GOF at x is G at f at x. There will be a preimage x itself when you start here. Let's write it properly here. For y belonging to natural, there exists y belonging to natural number such that GOF of y is y. So GOF is on. You can check, 5, it's going to 5, 4, it's going to 4, 3, it's going to 3, 2 is going to 2, 1 is going to 1, right? For everything you have a preimage. You take any number, you have the preimage, and that's the same number, right? So that is why it is onto. Then, but they want to say that f is not onto. Yes, f is not onto because this one is unrelated. 1 doesn't have a preimage. So, but f is not onto since 1 belonging to natural number could open. Does not have a preimage. That's it. So that's about the example, and it's not much of effort because everything is given to us. We have only implemented and we found out how this is not working. So that's about it. It's a voluminous exercise with 19 problems. So the remaining questions we'll be taking it up in the next video. Thank you.